In 2009, NASA launched the Lunar Reconnaissance Orbiter, a bold mission to map our moon in such detail that future crewed and robotic missions could not only land safely, but also go to scientifically important locations. With the start of the Artemis missions, the future is now, as NASA prepares to send humans to the lunar South Pole. This region is of particular scientific interest because it features areas of extended sunlit illumination and permanent shadow, is known to contain resources like water, and sits on the rim of the oldest impact crater in the Earth-Moon system. Over the years, LRO's suite of scientific instruments has delivered as promised, giving us incredible new views and data on this terrain, helping us build a roadmap for exploration. So follow this series as we take a look at how the LRO mission is laying the groundwork for Artemis science. One of the instruments on LRO is the Lunar Orbiter Laser Altimeter, or LOLA. It provides topographic data on the lunar surface, revealing slopes and surface roughness, helping us create models of lunar gravity and surface brightness, as well as high-resolution 3D maps of the moon. In this visualization, the colors correspond to different elevations found amongst the craters and mountains of the South Pole region. Having accurate elevation data is essential for landing site selection, surface navigation, identifying areas where resources can be found, and planning the design of future lunar infrastructure. In addition, studying the elevation and topography of the moon contributes to scientific research about its geological history, formation processes, and ongoing changes. By analyzing elevation data, scientists can learn more about the moon's past volcanic activity, impact history, and tectonic processes. The global terrain mapping by LOLA also makes it possible to simulate sunlight and shadow on the moon at any date in the past or future. Here, we see a visualization of the region in 2028, depicting the changes in shadowing in 2-hour intervals over the course of the year. This information is vital to Artemis for planning exploration endeavors, since the low sun angles and terrain of the South Pole produce a uniquely challenging lighting environment. In the years since LRO's launch, there have been over 60,000 orbits of the spacecraft and 10 billion laser shots at the lunar surface, making LOLA's data a vital resource for both human and robotic explorers that arrive at the South Pole in the coming years. It's one piece in how LRO is helping NASA usher in a new generation of lunar science.